is on models and rules for our global climate, advances in climate law and mathematics. And it's done together with an established law professor and a scholar from Winchester College in the UK, who's a young mathematician and climate striker. So I'm going to turn to my co-author to present the first part.
Climate risks are real, serious, and urgent. The justice challenge of our century, they affect the poorest and the most vulnerable first, but constitute an existential threat for all of humanity. Our greenhouse gas emission levels are still increasing, as are average temperatures, far above what's safe for our planet. And changes in weather patterns are already occurring, causing terrible loss and damage from flooding, hurricanes, and other extreme weather events. Risks of devastating heat waves, droughts, and wildfires are also rising exponentially, as you probably already know. Climate change hurts people, causing increases in poverty, disease, and famine as well. And valiant efforts are being undertaken. However, the current financial flows fall short of the needed levels to meet climate mitigation and adaptation goals across sectors and regions. Total investment in private, public, domestic, and international sectors needs to increase by a factor of 6 to 3 times greater than current levels across all sectors of economies and all regions of the world.
So
I'm going to pick up over here to.
And we've got a bit of a time delay, bear with us, but the international responses to these complex climate risks and challenges are important because while these global wicked problems are increasing in severity and impact, the impacts, the challenge, and the risks are not actually surprises. Indeed, the international community has been examining scientific data, raising the alarm, and struggling to negotiate responses for 3/4 of a century, as long as the United Nations has existed. And these international conferences and debates have been leading slowly to some solutions, or at least clearer definitions of problems, and in some cases, fragmented, incoherent, conflicting, and even overlapping attempts to act in collaboration. Law and policy innovations are, however, developing internationally and at national levels. And increasingly, these laws deploy mathematics. In the policy side, we have Goal 13, to take urgent action to combat climate change and its impact among the world's sustainable development goals, set as aspirational targets backed by binding law by the United Nations in 2015 and meant to be achieved by 2030. The Paris Agreement is the international agreement that stands for lawyers as the fixed star in the firmament, although it's backed by and supports the United Nations Framework Convention on Climate Change from 1992. This main legally binding international accord on climate presents a core triangle of obligations. First, countries commit, they pledge to take nationally determined, quantifiable, and progressive actions for climate mitigation and adaptation to keep warming below 2 degrees, striving toward 1.5. Second, these actions are incentivized by changes in financial flows and related technology transfer and other cooperative mechanisms. And third, the financing is backed by and supported by transparency and reporting, peer review, stock taking, a sort of a pledge and review ratcheting up mechanism. And this supports the Framework Convention on Climate Change objectives. The key articles for our presentation are Articles 2 and 3, which lay out the objectives of the Paris Agreement, not just the global temperature goal, but also the focus on increasing the ability to adapt and fostering climate resilience. And third, of course, finance flows, making them consistent globally with a pathway towards low greenhouse gas emissions and climate resilient development. And so in particular, to deliver on those objectives of the Paris Agreement, we have Article 6, 6.2, which lays out cooperative approaches, trading emissions, reductions and removals through international, bilateral, multilateral agreements. And also Article 6.4, the Sustainable Development Mechanism, which allows for offsets. It essentially, through the CDM, permits a company or another entity in one country to reduce emissions by essentially taking them out of our climate system and having them credited so they can sell to another company or entity in another country, which can then use these in order to comply with its own emission reduction obligations or towards the net zero world. And there's a supervisory body that oversees this international mechanism. Further and finally, in the Paris Agreement, climate change and climate finance under Article 9 is crucial. We've committed to over 100 billion per year towards global public and private finance by 2020. And while we haven't achieved it precisely, we're between 89 and 96 billion at the moment, depending on your estimates. Further, in Glasgow at COP26, asset managers came together and committed to align 132 trillion that they manage with the Paris Agreement. So we have a significant commitment to climate finance. And we have different mechanisms that have been developed under the Paris Agreement, including through the Global Environment Facility, the Green Climate Fund, and the new Response Fund for Loss and Damage that was agreed in Sharm el-Sheikh at the COP just a few months ago. So at the international level, we have some serious commitments that we need to be able to realize. For this, there is also, of course, a contribution that the law can make nationally and locally. Indeed, it's only by localizing the law sometimes that we can ensure that the international courts really reach their full potential. The law reform for climate finance shows us that in many areas, including emissions trading and carbon intensity in private enterprise, as well as climate finance and investments, everything from fossil fuel subsidy reductions, financing for renewables, and new technologies such as fusion power, to the laws and guidelines on financial services or the rules and registry governing net zero pledges by financial institutions, as well as their MRV, their monitoring, verification, and review processes, are particularly relevant. Further, and as we will look at in the final part of our presentation, the legal contributions to climate compliance are considerable. Not only can the law address climate risks and costs in corporate strategy, financial disclosure, and changes in cost of capital, but we can also improve our efforts to report on net zero and carbon negative pledges and to make those reports comparable, as we discussed in the last panel with some of our colleagues who were bringing forward ideas, including Christopher and Gael, as well as Andrea and Mikhail. Further, in terms of the establishment of clear rules and reliable governance systems, these are essential for emissions trading, carbon taxes, and carbon sequestration nature-based solutions to work, as we noticed in the session on carbon currency that we just attended. So our research looked into some of the new laws that are being adopted and how they're using maths. It's a survey. It's just the beginning. It's a collaboration between lawyers and mathematicians who aren't normally found in the same building, let alone the same room. And it looked in particular at how your mathematics is appearing in the law and whether it could be improved or even just compared. What we found, of course, is that climate finance can directly incentivize sustainable energy development in the law. Supporting Paris Agreement Article 2.1c and Article 9 on redirecting financial flows, governments are already deploying laws and budgets to provide climate finance for low carbon technologies. And this includes renewable energy and fusion power investments. In some cases, it is not clear how support levels are being determined, while in others, the laws include mathematical instructions. And for example, we looked at the IRA, the Inflation Reduction Act in the US, which is investing US $369 billion in emission reductions in sustainable energy infrastructure. And we looked at the EU's Renewable Energy Directive that sets binding targets for renewables deployment, as well as the UK's plans for fusion power technology development and Canada Budget 2023, which invests Canadian 20 billion to accelerate clean energy transition, green power, and infrastructure. Jona, can you explain what we found?
Sure. So in the EU Renewable Energy Directive, they provide an equation to calculate the annual carbon stock modifications caused by land use change as one example. The math here finds the difference between the reference and actual land use, accounting for biofuel production using the land.
Excellent, thank you. Now, the second area which we explored was emission trading systems. And we found that legal rules are being used to establish and maintain the stability of these systems. Supporting Paris Agreement Article 6.2 on cooperative approaches to emissions reductions and removals, governments are deploying laws to provide frameworks for their emission trading schemes. In several cases, these laws also directly include mathematical instructions. For instance, we looked at the EU Emissions Trading Directive of 2003, the UK Greenhouse Gas Emissions Trading Scheme Order of 2020, which essentially continues the UK carbon credit market after Brexit. Both of these schemes similarly set a cap on greenhouse gas emissions emitted by power plants, factories, and other facilities across sectors such as energy production, manufacturing, and aviation, aligned with the Paris Agreement, with individual allowances distributed to and surrendered by companies. This allows the companies to trade allowances, creating a market and a financial incentive to reduce their emissions and invest in cleaner technologies. We also looked at the Quebec and Canada emission trading system, Quebec and California emission trading system, which prices carbon with the cap and trade system as part of the Western Climate Initiative. And the proceeds, of course, go toward green economy and climate change action in Quebec and in California. Jona, can you explain the math we found?
Sure. So for calculating GHG emissions and factors, the EU Emission Trading System Directive from 2003 provides a calculation of the emissions from fuels. This here employs a relatively simple equation to account for different types of fuels and oxidation levels based on scientific data. As for the UK, the GHG Emissions Trading Scheme, or 2020, where they calculate the emissions reduction factors for small emitters and hospitals as one example. In this instance, they compare the total emissions of all installations with the total emissions from the small emissions list to convert it into a discount factor. Furthermore, in Quebec, they define the average intensity of emissions over a period of time and compare it with the reduction and reference intensity. Here, they take the sum of GHG emissions over time compared to the number of years and find the intensity of emissions by comparing it with the number of reference units given. They then use that in comparison to the intensity over the reduction time frame to allow for more benefits. Furthermore, in the California GHG emission cap and market, the market defines the market-based compliance obligation. Here, they calculate the GHG emissions by taking the sum of the specified and unspecified emissions and subtracting the adjustment factor and linked emissions.
Now, these instructions are provided in the law. One of the questions we started to ask ourselves was, of course, how many of the lawyers who are trying to implement this system are actually even capable of understanding and working through some of these calculations? That remains an open question. We looked at two other examples before we conclude. The first one, of course, is how laws set carbon taxes to price greenhouse gas emissions. Supporting Paris Agreement Article 4.4 on economy-wide absolute emission reductions, governments can deploy laws to put a price on carbon emissions, including through their taxes. In several cases, the laws also directly include mathematical instructions. In this instance, we looked at the Sweden Carbon Tax Act of 1990, which is seen as the precursor for most of the functioning carbon taxes to date, and also the British Columbia Carbon Tax Act of 2008, and the Canada Greenhouse Gas Pollution Pricing Act of 2018, which puts a price on the carbon emissions from provinces that do not have their own price, encouraging the transition to cleaner, more sustainable forms of energy. Finally, we looked at the controversial new 2023 EU Carbon Border Adjustment Mechanism, the CBAM, which not only introduces a carbon border tax on certain imported goods from countries with lower climate standards, preventing carbon leakage and avoidance of carbon pricing, but also requires importers to purchase emissions certificates equivalent to the carbon cost of EU production. It's aiming for a carbon neutral or climate neutral EU by 2050 and a reduction of emissions in the entire region at least 55% by 2030. So Jona, do you want to briefly provide our maths?
Sure.
Wrap up. Good wrap up.
Yep, we're on the last example.
So for the Swedish Carbon Tax Act, the math calculates a direct charge per unit of fossil fuel. For the British Columbia Carbon Tax Act, the math computes the charge based on prices determined by the law. And the Canada GHG Pollutions Pricing Act, where they calculate, as one example, a tax reduction for biogasoline and biofuels, in particular with mixtures they add in a proportion, they add in dependent on the proportion and reduction factor.
Excellent. And finally, CBAM, ouch.
Yes. The CBM mechanism calculates the specific embedded carbon emissions of simple goods and complex goods, where the math divides for simple goods the attributed emissions of goods by the quantity of the goods produced, with the complex goods including an embedded emissions factor for input materials.
So the last example that we looked at, and we're on our final 2 slides, it will take us 2 more minutes, was rules that can require companies to disclose climate risks. And this is the project we'd like to propose going forward in the discussions. Supporting Paris Agreement Article 4.4 on emission-wide absolute emission reductions and Article 9 on climate finance, governments can require traded companies to disclose and address climate risks. This requires accounting, modeling, and calculations, as we've seen in previous panels. We looked at the TCFD of 2022 in the UK. We also looked at the proposed Sustainability Due Diligence Directive 2023 in the EU. And then we checked the rules that are being proposed by the Securities and Exchange Commission of the United States and Canada's proposed climate disclosure for the TCFD mandates for banks, insurance companies, and pension funds based on the TCFD framework. And what did we find? Jona?
So here, unfortunately, we unfortunately found that the disclosures and mandates for stock requirements rely on accounting standards based on calculations which are often not provided nor readily available in the laws and codes being produced. The current directive and regulations for the UK and EU and the proposals for ones in the US and Canada demonstrate that calculations are necessary. However, they presently seem to leave precise determinations of risk monitoring accounted for, verified, or disclosed to companies. The rules here, thankfully, though, appear to still be under development, with
space for maths. So our initial findings are essentially, and this is our final slide, simply that mass models and rules are being deployed across climate law and policy innovations with many different uses across time. Greater transparency could improve engagement in climate lawmaking and reporting, including deployment of mass models and tools, leading to clearer implementation. We also think that there may need to be increased lawmaker mass literacy, or at least consultations with mathematicians to strengthen the law and policy frameworks and also to lead to improved climate compliance. Further research is needed, including next level comparative analysis of the legal mass measures and their effectiveness in the different countries. In at least 3 of our case studies, we were able to identify the same purpose being met, but through completely different mathematical models and instructions. And this is where we'd like to go deeper and maybe propose some further research. Thank you very much.